This is the first video in a series of videos to answer the question, what is the normal distribution and why is it so normal? Before we can even describe that normal distribution though, we're going to have a bit of background. In this video, we're going to be looking at two of the most basic statistics, the mean and the median. However, we're also going to look at something called an outlier. Now, these are all terms you are very likely already familiar with, so I encourage you to look at them with fresh eyes. I am constantly amazed at how much people overvalue these statistics, in particular the mean. These are descriptive statistics which describe and summarize a model or a process. In this case, they describe the center of our data. I'll define what I mean by center in a moment. In fact, to understand these statistics at all, let's go ahead and look at an example. As I said earlier, statistics is the art of describing a complex process with a simpler model. So let's go ahead and look at our first process. This is the process of waiting for a bus. As part of our commute, we need to ride a bus, and so we arrive at the bus stop and we wait for the bus to arrive. This bus is very slow for whatever reason, so we normally end up waiting quite a while. We want to better understand this process, so we start writing down how long we have to wait and keeping a record. As you can see on the screen, I have about 2 weeks worth of wait times. You can also see that one time the bus took a really long time to arrive. Maybe it broke down and so I had to wait for the following bus. Now, let's pretend we know nothing of statistics and a friend asks us how long the wait is for the bus. We might say something like, about 30 minutes plus or minus 5. This is a model. It's a very simple model. It captures the process fairly well. It's a little ambiguous. Is plus or minus 5 the worst case, the average case? It's not really clear. Also, where did that 30 come from? Well, it's kind of in the center of all of our data. I've kind of threw it on a number line here. We can see we have some 25s and some 35s, but they're more or less the same on either side, so 30 ends up kind of being the center of our data. So let's look at how we might compute this mathematically. To start with, we'll look at the mean, which is the more popular approach. To calculate the mean, we simply add up all our values, and we divide by the number of values we have. And as you can see here, we get around 33 minutes, which is a little larger than my mental model came up with. These things do cancel out, but we have this value way out here on the right, and it's pulling our mean a little bit to the right of 30. It's a little bit larger. This 60-minute ride over here is called an outlier, and the normal statistical answer for what is going on is that the mean is not robust to outliers. It is influenced by them. We will see in a minute if that's a good thing or a bad thing, but first let's look at a method that isn't influenced by outliers, the median. To compute the median, we have to sort our values. As you can see here, I've labeled them from 1 to 9, smallest to largest, and then we simply pick the middle value. It would be 4.5 since we have 9 values, so let's just pick either 4 or 5. It doesn't really matter, and in this case it doesn't matter at all. The median, as we can see, is 30 minutes. The presence of the outlier bus time is not influencing us from getting that true center. So which approach is better? Well, one approach to answering this question that I hear a lot is that the outlier is bad data, and it shouldn't even be there, and the mean should be preferred. The thinking is that outliers represent garbage data, and so then we can just fall back on our old software development maxim, garbage in, garbage out. Now, in many cases, this argument can be compelling. Outliers are often the result of garbage data. For example, someone may not understand the question they're being asked and give a bad answer, like supplying their height in centimeters instead of feet. Or the person giving a survey may make a typo when they're entering the answer in, and they add a few extra zeros or something. However, these are not the only, and in some cases not even the most common, source of outliers. Just look at our bus data. It wasn't a data entry error that a bus took 60 minutes. It isn't a case of garbage data. Instead, this comes from our second possible source of outliers. Outliers can come from parts of the underlying process that are not described by the model. Remember, our simple model was 30 minutes plus or minus 5. This doesn't account for buses breaking down. We could state 30 minutes plus or minus 5, but sometimes the bus breaks down and then it takes 60 minutes plus or minus 5. That model is more accurate and it accounts for our data. However, if you look at that model closely, you can see there's two centers. There's the 30 minutes center, how long the bus takes when it's on time, and there's the 60 minutes center, how long when the bus is late. So it stands to reason that we can't compute a single meaningful mean anyway from such a model. So when it comes to the mean and the median, the answer is slightly less clear. You should use the method that is appropriate for your situation. Use the mean when you want to include the effect of outliers, and use the median when you don't want to include the effect of outliers. So let's look at an example. Let's say we're building a system to detect when a bus is broken down, and it calls a taxi. How do we know when the bus is broken down? Well, if it's much further away from the center than expected, then the bus is probably broken down. We do not want to include outliers because we're trying to figure out if our data is in the typical on-time scenario or not. So we want to compute the center of the typical on-time scenario, and we don't want those outliers to be part of that center. So we should use the median. On the other hand, let's assume we are comparing two bus routes. In this case, the fact that the bus is really late sometimes, we'll assume we aren't calling a taxi in this scenario, it's a pretty big deal. Even if another route is a little bit slower, if that other route never breaks down, then maybe we should choose that route. To make it simple to compare the two routes, we can use the mean. The approach with the lower mean is then chosen. We do want to include outliers in this case because they're part of our overall wait time, so we should use them in that comparison. So the moral of the story today is that the mean and the median help you find the center of your data. Outliers can come from garbage data, but they can also come from parts of your process that your model doesn't cover. Whether you use the mean or the median depends on whether you want to include the effect of outliers or not, and that depends on the problem that you're trying to solve.